Hey, let's solve some more equations. 3 times the log base 2 of x minus 1 plus the log base 2 of 4 equals 5. Okay, let's see if we can take this left side and combine it into one big log of something. Using those properties from the last section. First of all, we can take 3 times the log base 2 of x minus 1 and write it as log base 2 of x minus 1 to the 3 power. And now we can take this sum of logs, log base 2 of x minus 1 to the 3 plus log base 2 of 4, and combine that into log base 2 of x minus 1 to the 3 times 4. So now that the left side is just one log of something, we want to undo that log with an exponential function. Since it's a base 2 logarithm, we need to undo it with a base 2 exponential function. So 2 to the log base 2 of 4 times x minus 1 to the 3rd power equals 2 to the 5 power. Okay, and what is 2 to the 5 power? It's 32. So 4 times x minus 1 to the 3rd power equals 32. Divide both sides by 4, and you get x minus 1 to the 3rd power equals 8. We can undo this 3rd power by taking cube roots. X minus 1 would be the cube root of 8, which would be 2. And finally, x is 3. If you want to check that in the original equation, if x is 3, x minus 1 would be 2. The base 2 logarithm of 2 would be 1, because that's the power you have to raise 2 to get 2. And then 3 times 1 would be 3. Meanwhile, over here, the base 2 log of 4 would be 2, because that's the power you have to raise 2 to get 4. So we got 3 plus 2 equals 5. Next example, log, and since there's no little subscript showing what the base is, this is a common log, a base 10 log. Log of 2x plus 1 equals 1 plus log of x minus 2. So there's a log on both sides, but there's also this 1 plus that isn't a log. Let's see if we can get just one log. First, I will subtract this log on both sides. So it's log of 2x plus 1 minus log of x minus 2 equals 1. Now to combine these two logs, we've got a property for this. Log of one thing minus log of another equals log of 2x plus 1 divided by x minus 2. Now, how do we undo this log? How do we get the log out of the way? It's a base 10 logarithm, so the inverse that undoes it is the base 10 exponential function. We need to take 10 to the log of something to get just the something. So do that to both sides of this equation. 10 to the log is just 2x plus 1 over x minus 2, and then on the other side, 10 to the 1 power would just be 10. Then get rid of the fraction by multiplying both sides of this equation by the denominator x minus 2. Then multiply out the 10 times x minus 2 to get 10x minus 20. There, fixed it. And then finish solving from there. Add 20 to both sides, subtract 2x on both sides. You get 8x equals 21. Divide both sides by 8. X equals 21 over 8, or 2.625. Another example, 4 to the 2x minus 1 equals 64. What can we do with this? We can undo the exponential function 4 to the, with its inverse, the base 4 logarithmic function. Log to the base 4 of 4 to the something is just the something. So we're taking base 4 logarithms of both sides. So on the left side, that just undoes the exponential function and gives us 2x minus 1. On the right side, the base 4 logarithm of 64 is 3. That's the power you have to raise 4 to get 64. And from here on out, it's pretty easy. Add 1 to both sides, divide both sides by 2, x equals 2. Now, another way we could have figured this out is right at the beginning, if you recognize that 64 was 4 to the third power, you could have said, oh, on one side we got 4 to the 2x minus 1. On the other side we got 4 to the 3. So 2x minus 1 must equal 3. And then just take it from there. Okay, how about this one? 3 to the x power equals 50. Okay, one way we can deal with this, we could translate this into logarithmic form. Right now it's in exponential form, something to the something equals something. But what would it look like in logarithmic form? It would be log base 3 of 50 equals x. Because that's what log base 3 of 50 means. It means the power you have to raise 3 to get 50. So the number we're looking for to satisfy this equation is the power you have to raise 3 to get 50. It's the logarithm base 3 of 50. Okay, but then how would we figure out what that is? How would we get a number for log base 3 of 50? Okay, remember that change of base formula we looked at last time? To find any base logarithm of a number, we can calculate that by just taking the common log of that number divided by the common log of the original base. Or we can use natural logs. We can take the natural log of that number and divide by the natural log of the original base. Either way, it's going to come out the same. And let's see what we get on the calculator when we do that. Just for fun, I'll do the ln version, but you'll get the same thing either way. Hey, calculator, what is the ln, the natural logarithm of 50, divided by the ln of 3? And it tells me it's 3.560876795. Okay, that sort of makes sense. 3 would be too small because 3 to the 3 power is 27. 4 would be too big because 3 to the 4 power is 81. So somewhere in between is the power we're looking for. And it turns out that that's about 3.561 if we want 3 places after the decimal point. Now, another way to go about solving this, another approach would be, okay, take this equation and take logs of both sides. Since 3 to the x equals 50, that means the log of 3 to the x equals the log of 50. And here I've written it as common logs, but we could have also used natural logs. And now we use that property that says that the log of something to a power is equal to the power times the log of the something. So now it's x times the log of 3 equals the log of 50. Now what if we want x by itself? Right now we have x times something else, divide both sides by the something else, and we get x equals the log of 50 divided by the log of 3. So again, same thing, ends up being 3.561. How about 10 times e to the x equals 357? Well, if we had e to the x by itself, I know what we would do then. But how can we get e to the x by itself? Well, undo the 10 times by dividing by 10. So divide both sides by 10, you get e to the x equals 35.7. Now, how do we go from e to the x to just x? How do we undo the exponential e to the x function? With the natural logarithm function. ln of e to the x is just x. So we take ln of both sides, ln of e to the x is just x, and ln of 35.7 is, well, it's whatever the calculator says it is. And the calculator should give you about 3.575. So that's the solution to that equation. Okay, one more. E to the 2x minus 9e to the x minus 36 equals 0. You know, if I kind of squint my eyes, that kind of looks like a quadratic equation. Like it's got a squared term and then a variable in the middle and a constant term. like an ax squared plus bx plus c equals 0 kind of thing. Except instead of just something squared, this is e to the 2x and this is e to the x. But you know what? E to the 2x is e to the x squared. If you start with e to the x and then take that to the 2 power, you get e to the x times 2 power. That is e to the 2x. So this is like a quadratic equation where the variable, the role of the variable, is being played by e to the x. We have that squared, we have that, we have a constant term. If you want to make it look even more like a quadratic equation, you can make a little substitution and let u stand for e to the x. Then it would be u squared minus 9u minus 36 equals 0. Now, if we just go ahead and solve that, we can factor u squared minus 9u minus 36 into u minus 12 times u plus 3 equals 0. So u equals 12 or u equals negative 3. But remember, u is really e to the x in disguise. Remember, when I make a substitution, I like to use the letter u because u reminds me you better remember to unsubstitute. So now I'm going to rip the mask off the u and see that that's really e to the x equals 12 or e to the x equals negative 3. And how do we go from e to the x to just x? We've seen that before. You undo the e with ln. Take the natural log of both sides. Ln of e to the x is just x, so x equals the ln of 12, or the ln of negative 3. Now the ln of 12 is about 2.485. The ln of negative 3 is undefined. You can't have the ln of a negative number. So the only solution we get, the only real solution to this equation is where x is, well, the exact answer is the natural logarithm of 12. The decimal approximation is 2.485. Okay, now that I've taken you through some examples, now it's time for you to do the homework and try solving some for yourself.